So hello guys, welcome to today's study session. Today we are going to study about HTTP. So let's get into the roadmap. So this is like roadmap.sh, and we are on the front-end developer roadmap. So in the previous session we did how does the internet work. Now we are going to continue this roadmap by studying what is HTTP. So we are going to start with this article, everything you need to know about HTTP. So I said in one of my reels that I will be using AI to make my videos more efficient and refine the process at GPT. And I just copied the URL of this website, as you can see, and I asked ChatGPT give me list of topics covered in this web page. So you can see, you can kind of see there, there is no you index here. So it just gives me like an index, like what topics are covered. So what is HTTP? We will, like, in this article we will see what is HTTP and the versions of HTTP. So it's like the timeline, how it's like landmarks, what milestones. So yeah, and then I asked ChatGPT to give me like 10 to 15 key questions to cover the entire web page. So these are the questions you will be able to answer after going through like this web page. So we will like be coming back to these questions as we cover this you know web page. So let's start reading. I have like a notepad and a pen in my hand. If you want, you can also hold word, so we can just kind of take notes and keywords. So let's start. Everything you need to know about HTTP. HTTP is like a protocol that every uh, web developer should know, as it powers the entire web. Knowing HTTP can certainly help you develop better applications. So यहाँ पे बेसिकली क्या कह रहा है कि HTTP बेसिकली प्रोटोकॉल है, ठीक है. प्रोटोकॉल इज लाइक अ सेट ऑफ रूल्स, you can say, and that every web developer should know it to like develop better applications. In this article I will discuss what HTTP is now, how it comes to be, where it stands today, and how we get here. Okay, so basically क्या HTTP है, how it came to be, like कैसे मतलब इसका डेवलपमेंट हुआ या फिर कैसे काइंड ऑफ इन्वेंशन हुआ, when it where it stands today. So like अभी क्या प्रेजेंट में क्या पोजीशन है HTTP की, and how we got here, like the history of it, as I told you. So we will start with HTTP. So I will write HTTP. First thing first, what is HTTP? HTTP is like a TCP IP based application layer communication protocol that standardizes how clients and servers communicate with each other. So basically कुछ समझ नहीं आया. So basically we will ask ChatGPT to explain. I will just use the calling feature here. Allow. Explain me this in simple terms. What is HTTP? HTTP is a TCP IP based application layer communication protocol that standardizes how clients and servers communicate with each other. So ऐसे मतलब like as I told you, like HTTP is like a set of rules, वही protocols. Okay, and let's see your web browser, the client, and the web server talk to each other. तो बेसिकली HTTP करता क्या है, वो आपके सर्वर को, यानी कि आपके ब्राउज़र को, यानी कि वेब ब्राउज़र को आपके सर्वर से बात करने देता है, ठीक है. इट इज़ अ लैंग्वेज दैट दे वोंट अंडरस्टैंड, अलाउ यू टू लोड वेब पेजेस, सेंड एंड रिसीव डेटा, एंड बेसिकली मेक्स द वेब वर्क स्मूथली. ओके, सो ये बहुत बेसिक वर्जन में, ये थोड़ा सा इसमें थोड़ा सा कन्फ्यूजिंग लैंग्वेज दे रखा है ये सब चीज़ें कि भाई इट्स लाइक TCP IP बेस्ड एप्लीकेशन लेयर कम्युनिकेशन प्रोटोकॉल. बट यहाँ बेसिकली सिंपली बता दिया है कि भाई प्रोटोकॉल मतलब क्या, सेट ऑफ रूल्स हैं, और आपका क्लाइंट क्या है, वो आपका वेब ब्राउज़र है, और जो वेब सर्वर है जिससे आप बात करना चाहते हो, वो इन दोनों को बात करने के बीच का एक माध्यम देता है. Okay, so let's continue. It defines how content is requested and transmitted across the internet. Okay, मतलब कैसे जो डेटा है वो बेसिकली रिक्वेस्ट करेगा और ट्रांसमिट होगा थ्रू द इंटरनेट अक्रॉस द इंटरनेट बाय एप्लीकेशन लेयर प्रोटोकॉल. I mean that it simply a abstraction layer that standardizes how होस्ट. अब होस्ट बेसिकली क्या होते हैं, दो टाइप के होस्ट हैं. एक क्लाइंट है यानी कि आपका वेब ब्राउज़र, और एक जो सर्वर है यहाँ पे बेसिकली आपकी वेबसाइट, जो वेबसाइट आप एक्सेस कर रहे हो वो स्टोर्ड है, वो कम्युनिकेट कैसे करेगी. ठीक है, वो बेसिकली ये एप्लीकेशन लेयर डिसाइड करेगा एंड बाय द एप्लीकेशन लेयर प्रोटोकॉल. लेट मी जस्ट आस्क इन सिंपल टर्म्स. Explain this also. By application, sorry, let's start here. It defines how communication is requested and transmitted across the internet. By application layer protocol, I mean that it's simply a abstraction layer that standardizes how hosts, client and server communicate. HTTP depends upon a TCP IP to get requests and responses between the client and server. By default, TCP port 80 is used, but other ports can also be used. HTTPS, however, uses port 443. Okay. So now can you just kind of give me the keywords in like the like both previous answers you gave me, like just give me like a combined definition, like defining keywords for HTTP. So basically now we have the keywords, so you don't have to like understand all of this. Like it is like kind of given in like a very confusing language. As you can read it, like you won't understand much, but now we have like a simpler version of it. So basically now you understand the protocol is like a set of rule. Application layer, it is like the topmost layer of internet's architecture. So basically अगर आपने internet architecture पढ़ा होगा तो you will understand what it is. Actually in my previous video I forgot to cover the internet's architecture, that's why I also don't have an idea. But yeah, I will maybe cover it in like a recap video when I will create like a recap video for my previous videos. But yeah, so application is like the top layer of the internet architecture where HTTP operates. So basically ये this is like the keyword. So basically अगर आपसे कोई पूछेगा कि where does like the HTTP operates, मतलब कहाँ पे वो रहता है, कहाँ से वो फंक्शन करता है, तो you will say the top layer of internet's architecture, okay, which is application layer. Client server क्या था, client server वही, there are two ends of communication with the client usually being like your browser, and the server where the server where the website is hosted. And TCP IP क्या होता है, the underlying foundation that ensures data is transmitted reliably. So it is also a protocol, and what it ensures is कि आपका डेटा जो है रिलायबली पहुंच जाए जहाँ तक आपको पहुँचाना है. ठीक है. एंड पोर्ट्स डिफ़ॉल्ट क्या होता है, डिफ़ॉल्ट पोर्ट इज़ लाइक 80 फॉर HTTP एंड 440 फॉर HTTPS. ओके, तो ये डिफ़ॉल्ट पोर्ट्स हैं, आपको नंबर याद कर लेना चाहिए. याद हो जाए तो कोई ऐसा मतलब कोई बहुत ही हार्ड एंड फास्ट रूल नहीं है. रिक्वेस्ट एंड लाइक मतलब बाय डिफ़ॉल्ट ये 80 पे ही होगा लैंड और 443 पे. अब जब तक आपने बेसिकली अपने पोर्ट्स को कॉन्फ़िगर नहीं किया होगा वो डिफ़ॉल्ट पे यही वाले नंबर पे रहेंगे. ठीक है, तो ये लाइक डिफ़ॉल्ट है आपका पोर्ट्स. Requests and responses, the way data is asked for and delivered between the client and server. ओके, तो बेसिकली ये बेसिकली दोनों का एक तरह से वो हो गया है डेफिनेशन कि जब डेटा को रिक्वेस्ट करते हो तो आप आस्क करते हो डेटा के लिए, और रिस्पॉन्सेज क्या होते हैं, वो डिलीवर्ड बिटवीन द क्लाइंट एंड सर्वर, तो वो रिस्पॉन्स हो जाएगा. तो लेट्स गो टू लाइक द HTTP 0.9, the one liner. Let's just so like kind of help me with this one also, like kind of uh, kind of make it easy for me to understand. I'm gonna start HTTP 0.9, the one liner, 1991. The first documented version of HTTP was HTTP 0.9, which was put forward in 1991. It was the simplest protocol ever, having a single method called get. If a client has to access some web page on the server, it would have made the simple request look below get slash index.html, and the response from the server would have looked as follows: response body, connection closed. That's it. The server would get the request, reply with the HTML in response, and as soon as the content has been transferred, the connection will be closed. There no there were no headers. Get was the only allowed method. Response has to be HTML. As you can see, the protocol has really has nothing more than being a stepping stone for what was to come. So when we say that there was a method called get, it is literally like a function. So can you give me a summary of keywords in HTTP 0.9? So as you can see, get is like a function. If you have done programming in Java, you say methods only, but in function you call it in other language, in C also, C++ also, you create function. So as you create a function and you give it a name, in this HTTP they gave the function the name get. Okay, and what it does, it's like a what it does it here is the get method, the only function used to request resources. So when you say that, where was the example, get index place index.html, then the server would just respond with a HTML content. Once the content was sent, the connection would close. Okay, and simplicity, there was no header, no other methods. There you say simplicity, no headers. What you mean by headers, by the way? Was HTTP 0.9 was hard coded to only send HTTP, or they did not even think of other extensions back then? So it was kind of hard coded to have just HTTP files, you are saying? Okay, I just went into a deep dive here, but yeah, I was kind of curious, so I had to itch my curiosity here. So yeah, so it was just meant to serve basic HTML, plain HTML content, raw HTML content, as it says. There were no additional metadata, how who was the author of this page and all that metadata they have, or in which language this page is, web pages. They don't have that metadata. There was no headers there. There was no other method. There was only one function, which was get. Okay, and the server, after the server sends the response, the connection is immediately closed. So there is no the connection is not going, nowadays you are always on the internet, you are getting notifications from Instagram, you are getting WhatsApp notifications, all the social media. So you are always connected, there's always data going back and forth happening, even if you don't see it or you don't notice it. But back then, when there was HTTP 0.9, it just after you requested and they send you the data, the connection is closed completely. So yeah, let's go into HTTP 0.1 1996. So I'm gonna do it again. Okay, so now help me explain this. HTTP 0.1 1996. In 1996, the next version of HTTP, that is HTTP 0.1, evolved that vastly improved over the original version. Unlike HTTP 0.9, which was only designed for HTML responses, HTTP 1.0 could now deal with other response format, that is images, video files, plain text, or other uh, content types as well. It added more methods, that is post and head, request and response formats got changed. HTTP headers got added to both the request and responses. Status codes were added to identify the response. Character set support was included. Multi-part types, authorization, caching, content encoding, and more was included. Here's how a sample HTTP 0.1 request and response might have looked like. Get http get slash http slash 0.1 host cs.fyi user agent mozilla slash 5.0 and Macintosh Intel Mac OS X 10 underscore 10 underscore 5 except like there's like a asterisk slash asterisk. So as you can see, alongside the request, client has also sent its personal information required response type etc, which is http slash 0.9. Client could never send such information because there were no headers. Example response to the request above might have looked like below. http slash 0.5 200 OK. Content type plain slash text. Content length 137582. Expires Thursday 5 December 1997 16 00 GMT. Last modified Wednesday 5 August 1996 15 dot 55 GMT. Server Apex, what would you Apache 0.8584. Response body connection closed. In the very beginning of the response, there is http slash 0.1 1.0. http follows the version number, then there is the status code 200 followed by the reason uh, phase or description of the status code, if you will. In this newer version, request and response headers were still kept as ASCII encoded, but the response time could have been of any type, that is, images, video, HTML, plain text, or any other content type. So now the server could send any content type to the client. No, not as long after the introduction, the term hypertext in HTTP became uh, sem misnomerous. HMTP or Hypermedia Transfer Protocol might have made more sense, but I guess we were stuck with the. One of the major drawbacks of HTTP 1.0 were you couldn't have multiple requests per connection. You couldn't have multiple requests per connection. That is, whenever a client will send something from the server, it will have to open a new TCP connection after the single request has been fulfilled. Connection will be closed, and for any next requirement, it will have to be on a new connection. Why is it bad? Well, let's assume that you visit a web page having 10 images, 5 style sheets, and 5 JavaScript files, totaling 220 items that needs to be fetched when request to that web page is made. Since the server closes the connection as soon as the request ends being fulfilled, there will be a series of 20 separate connections where each of the item will be served one by one on their separate connections. This large number of connections result in a serious performance hit as required. Requiring a new TCP connection imposes a significant performance penalty because of three-way handshake followed by slow start. Three-way handshake. The three-way handshake is its simplest form is that all the TCP connection become beginning with the third way handshake is which the client and the server shares a series of series of packages before starting to share the application data. SYN, client picks a random number, let's say X, and send it to the server. SYNACK, server acknowledges the request by sending a ACK package back to the client, which is made up of a random number, let's say Y, picked up by the client, and the number X plus 1, where X is the number that was sent by the client. ACK, client increments the number Y received from the server and send a ACK package back with the number Y plus 1. Once the three-way handshake is completed, the data shared between the client and the server may begin. It should be noted that the client may start sending the application data as soon as it dispatches the last ACK package. The server will still have to wait for the ACK package to be received in order to fulfill the request. However, some implementations of HTTP 1.0 tried to overcome this issue by introducing a new header called connection keep alive, which was meant to tell the server, hey server, do not close this connection, I need it again. But still it wasn't that widely supported and the problem still persisted. Apart from being connectionless, HTTP also is a stateless protocol. That is, server doesn't maintain the information about the client, and so each of the request has to have the information necessary for the server to fulfill the request and its own without any association with association with any old requests. And so this adds fuel to the fire. That is, apart from the large number of connections that the client has to open, it also has to send some redundant data on the wire, causing increased bandwidth usage. So can you give me like the keywords for HTTP 1.0 too? So I actually know what is what does get function, like the get method does, but I don't understand like the post and the head. So now we have got now we understand what like get means, and we understand like the post is used to send data to the server, and head is used for retrieving just the headers, like the metadata, like when was this web page created, or like how much, like what is like the size of this web page, like how much MBs, or like the length of the web page, you understand what I mean. And they added like the content types also, like now it the HTTP 1.0 kind of supports like multiple formats and methods. We have discussed headers, added request and response headers, allowing more data, like more metadata and control. Status codes, let me see. So there was like only one status code at that time when like HTTP 1.0 was made, like only like 200. uh, so okay, like as you can see now, like there was uh, 1 2 3 more code, status code, and I'm very sure you must have seen like 4.404 error. Like I have seen like 4.404 error a lot, and like the 100 one also, like the internal server error a lot. So, and that is covered. And character set supports for different character encodings. You have said like there's like a character sets support for different character encodings in like HTTP 1.0. What do you mean by character sets? Like it's like a font thing, or like there are like special character support? Okay, so like that is also cleared. And caching, implementing caching mechanism to improve performance. So basically caching karta kya, basically it just stores data. So like it is like stored in the memory, so like when you want to like kind of it is like that kind of data which like you need like constantly you need it. Let me just confirm. So you have said caching, implemented caching mechanisms to improve performance. So जैसे कि what I can understand from this is like you kind of cache like data in your memory which you will need constantly. So you kind of save it for like in your memory, in your RAM, so you can access it quickly. And your like CPU also has some cache memory. So is it that only? So as you can understand, I was kind of on the right track, but I just did not have the words to explain it. So maybe now you understand it like more clearly. If you want to like read all of this, so you can just pause the video and you can read it for yourself also. And I kind of understand it, like I have the thing for it. Yeah, but I will like take some time to process the information for myself also. Authorization, it is like the same thing like login password, like you have your Gmail. So like whenever you log in like a new computer, it asks for your password, and maybe it might also send like a OTP on your phone also to like what would you say, like two-factor authentication. That's what it is called. So yeah, that's like the like authorization part. Persistent connections, introducing the connection keep alive header that was not widely supported at first. Stateless, each request was independent, meaning no session persistence. So basically होता क्या था, like you used to make a request and then it used to fulfill the request and the connection was closed. So like it was kind of like every request needs to be like on like a new connection, and then like the server like will do the handshake thingy, and then they will like kind of verify, and then they will send like the data from the server will be sent to your client. So yeah, it was kind of like a lot. It was kind of intensive, like you had to like it would take a lot of time, you know and the performance impact, the need of multiple connection led to performance overhead. As like in the example also, when I was reading it, like they told like, oh, let's imagine there is like a web page which has like 5 images. So each of those images will take a separate connection, and once like the first like you will you know first the request will be sent, then the handshake will happen, then the server will kind of send the photo to the client, and then the connection will close, and then again it will send like a request for another photo, then the handshake will happen, and then like the server will send it to the client and the connection will close. So it takes a lot of, as you can see, like it is taking so much time and unnecessary hardware, like it is taking so much like hardware performance to happen like a simple task. We don't even like think about these stuffs nowadays. We just like open a web page and we open like YouTube, and there like 15 videos pop up. You can even like hover on the video like in YouTube, and you can see the like preview of the video as well nowadays. So like we don't even care about this stuff. But back in the days, like all of this were kind of like, damn, you know what I mean, like how far we have came from that. So let's start with like HTTP 1.1 in like 1997. Oh my god, it's kind of a long one. Oh, let me just drink some water and I will be back. So I am back. Drink some water, bro. Like I was feeling so thirsty after reading so long. Let's do this one also. So explain me this. I'm going to read HTTP 1.1 1997. After merely 3 years of HTTP 1.0, the next version, that is HTTP 1.1, was released in 1999, which made a lot of improvement over its predecessor. This major improvements over HTTP 1.1 includes new HTTP methods were added, which includes put, patch, options, delete. Host name identifiers in HTTP 1.0, host headers weren't required, but in HTTP 1.1 made it required. Persistent connections were discussed above. In HTTP 1.1, there was only one request per connection, and the connection was closed as soon as the request was fulfilled, which resulted in acute acute performance hit and latency problems. HTTP 1.1 introduced the persistent connection, that is, connections were not closed by default and were kept open, which allowed multiple sequential request sequential requests to close the connections. The header connection close, close had to be available on the request. Clients usually send this header in the last request to safely close the connection. Pipelining, it also introduced the support for pipelining, where the client would send multiple requests to the client to the server without waiting for the response from server on the same connection, and server had to send the response in like the same sequence in which the requests were received. Which but how does the client know that this is the point where the first uh, response download completes and the content for the next response start? You may ask. Well, thus solve this to solve this, there must be content length header present, which clients can use to identify when the response ends and it can start waiting for the next response. It should be noted that in order to benefit from persistent connections or pipelining, content length header must be available for the response, because this would let the client know that the transmission completed and it can send the next request in normal sequence way of sending requests, or start waiting for the next response which pipelining is enabled when pipelining is enabled. But there was still an issue with this approach, and that is, what if the data is dynamic and server cannot find the content length beforehand? Well, in that case, you really can't benefit from persistent connections, could you? In order to solve this, HTTP 1.1 uh, included chunked encoding. In such cases, server may omit content length in favor of chunking in favor of chunked encoding. More to it in the moment in a moment. However, if none of them are available, then the connection must be closed at the end of the request. Okay. However, if none of them are available, then the connection must be closed at the end of request. Chunked transfers in case of dynamic content, which when the server cannot really find out the content length when the transmission starts, it may start sending the content in pieces, chunk by chunk, and add like a content length for each chunk. When it is sent, and when all the chunks are sent, that is when all the chunks are sent, that is whole transmission has completed, it sends an empty chunk, that is like the one with content length set to 0, in order to identify that client that transmission has completed. In order to notify the client about the chunks transfer, server includes the header transfer uh, encoding chunked. Unlike HTTP 1.0, which has basic authentication only, HTTP 1.1 included digest and uh, pro what is like digest and proxy authorization, caching, bit ranges, character sets, language negotiation, and what is like client cookies, enhanced compression support, new status codes, and more. I'm not going to delve about all the HTTP 1.1 features in this post, as it is like a topic in itself and you can already find a lot about it. The one of the documentation that I would recommend you to read is like key differences between HTTP 1.0 and HTTP 1.1, and there is like a link to original RFC for the overachievers. HTTP 1.1 was introduced in 1999 and it has been a standard for many years. Although it improves a lot over its predecessor, with the web changing every day, it starts to show its age. Loading a web page these days is more resource intensive than it ever was. A simple web page these days has to open more than 30 connections. Well, HTTP 1.1 has persistent connections. Then why so many connections, you say? The reason is in HTTP 1.1 it can only have one outstanding connection that any moment of at any moment of time. One point the HTTP 1.1 tried to fix this by introducing pipelining, but it didn't completely address the issue because of the head of line blocking. When a slow or heavy request may block the request behind, and once a request gets stuck in the pipeline, it will have to wait for the next request to be fulfilled. To overcome these shortcomings for HTTP 1.1, the developer started implementing the workarounds. For example, using of spreadsheets, encoded images in CSS, single ham humus uh, single ham humus CSS and CSS and JavaScript file, domain sharding, etc. So can you give me like the keywords for it now? Yeah, so I have a lot of questions now. What does these new methods do? Like you can say like put, patch, delete options. Like I don't understand like what they actually do. And second is like host headers required a virtual hosting. What is a virtual hosting? And yeah, explain me this first. Let me just call her again. So yeah, I read like virtual hosting, and from reading like what like the host like header does is like let's imagine like a big like a server rack, and there is like multiple websites hosted on that server. So like the virtual hosting is like okay, they are on the same server, but like the host header is what allows multiple hosting to coexist on a single server. Am I getting it like getting it right? So like the single server, like a single machine can hold and kind of host multiple websites. So yeah, I got that right. And then we got like what does like the put does. Put is like when you send like a put request, you are basically replacing the content at that URL with like the data you are providing. So जैसे कि इसका सबसे बेस्ट एग्जांपल बताऊँ क्या होगा? जैसे आप लोग बेसिकली अपना इंस्टाग्राम पे अपना बायो अपडेट करते हो, तो बेसिकली क्या होता है, पहले अपने बायो पे कुछ रखते हो, तो बेसिकली वहाँ पे एक चीज़ लिखी, वहाँ पे एक लाइन लिखी हुई है, जैसे मान लीजिए maybe you were like studying in school and now you are going to high, like you are now going into like college. So you are like changing your ki, oh I'm a high schooler, now you're changing it to like, oh now I'm like doing diploma in computer science, so you're just kind of you're basically replacing the content at that URL with your data, with the data you provide. Okay. And the next is like patch. It is like made like a partial updates to the resource. So like इसका सबसे best example, come on, like I am a gamer. आप लोगों ने अपना पबजी और फ्री फायर अपडेट किया होगा, तो इसलिए आपका पबजी और फ्री फायर बेसिकली टोटली कितने का होगा, 2 या 3 GB का होता है, राइट? सो जब हम लोग पैच करते हैं या फिर नया अपडेट आता है, तो वो क्या होता है, 600 MB का होता है, 800 MB का होता है। वो पूरा गेम भले इतना मतलब 3 GB का होगा, बट उसमें वो 600 MB का ही एक पैच या फिर अपडेट आता है। तो यहाँ पर बेसिकली क्या, इट इज़ यूज टू मेक पार्शियल अपडेट्स टू द रिसोर्सेज। तो बेसिकली वही चीज़ है, रिसोर्स मतलब आपका वैसे फ्री फायर हो सकता है रिसोर्स, इट कैन बी लाइक इट कुड बी एनीथिंग। So it is instead of replacing the entire resource like put, इट पैचेस ओनली द पार्ट यू स्पेसिफाई। जैसे कि आपका पबजी है, तो जब विंटर आता है तो उसमें विंटर का एक थीम लग जाती है, स्किन आ जाती है, तो बेसिकली वो पूरा गेम फिर से लोड ना हो, वो लोग बेसिकली उस पर्टिकुलर जो चीज़ें होती है ना, जैसे कि मैप में थोड़ा बहुत स्नो ऐड करनी है, तो बस मैप को पूरे फिर डाउनलोड ना करना पड़े, जो से मैप के जो स्नो टेक्सचर्स है उनको डाउनलोड कर देता है गेम। तो दिस इज व्हाट लाइक इट्स लाइक अ वेरी इजी वे टू अंडरस्टैंड व्हाट पैच डज। डिलीट डिलीट इज लाइक वेरी सिंपल। डिलीट इज यूज टू रिमूव द रिसोर्स फ्रॉम द सर्वर। जैसे कि आपका इंस्टाग्राम पे आपने कोई इमेज डाउनलोड, आपने कोई इमेज पोस्ट करी इंस्टाग्राम पे अपने डॉगी के साथ, कोई इमेज आपने पोस्ट करी, और आपको बाद में लगा कि यार ये फ़ोटो अच्छी नहीं आई है, थोड़ी सी ब्लरी आई है, इस पे लाइक्स भी अच्छे नहीं आए, तो डिलीट कर देते हो। तो इसलिए वो डिलीट कहाँ से कर रहे हो आप? सर्वर पे आपने पहले पोस्ट करी तो वो अपलोड हो गई सर्वर पे, आपने सर्वर से डिलीट कर दी, तो वो डिलीट का एग्जाम्पल हो गया। ऑप्शन, दिस मेथड इज यूज टू फाइंड आउट द allowed method and other capabilities of the server for like a specified resource. It often uses like a cross origin resource sharing, pre-flight requests, letting the client know what's allowed. This method is used to find out the, I don't understand actually. What does like the options method does? Like I can read it, but can you explain it like to like a fifth grader? Like I want it to be like very simple. It is the best example I can get on my head right now is like when I open Instagram. So Instagram, like because this is my Instagram account, it shows me like the edit option for my bio. Okay, but if someone else will kind of from their Insta idea, they will kind of visit my page, they won't like they won't be shown the edit option on my bio. Am I getting it right? Okay, now we understand what the option does. So like I hope this session which I'm recording, like this recording might be a little longer than usual, but at least we are learning something. It's like an interactive way of asking like questions, and like the AI is helping me understand the concept better, and you can kind of learn from these examples, and you can make your own examples and comment them down below if you have some questions regarding like these, like I have some curiosity on these questions, you might also have some better analogies and questions, so you can you can kind of go down and comment. So yeah, let's go ahead. I think we did like these, and then we did like this, huh? So we are kind of, we were like, okay, it allows persistent connection pipelining, sending multiple requests without waiting for waiting for a response, with the response turning in order, with the responses turns in order. So basically क्या कहना चाह रहा है कि you send like you don't wait for the response, you keep sending request. That's like what, like that's like imagine like a pipeline, the water is always flowing. It, even if it's like not going through the other end, like it is not flowing, it is like there, like when you have like so you understand what pipelining is now. You can send multiple requests without waiting for the responses. That's what it is. And the responses returned in the same order. जैसे कि अगर आपने बेसिकली पहले इमेज वन को रिक्वेस्ट करा, तो आपको पहले इमेज वन ही मिलेगी, फिर आपको इमेज टू मिलेगी, फिर इमेज थ्री मिलेगी आपको सर्वर से आपको वापस, ठीक है? तो आप जैसे जिस ऑर्डर में आप रिक्वेस्ट करते हो, उसी ऑर्डर में आपको सर्वर वापस देता है, आपको काइंड ऑफ आपकी रिक्वेस्ट फुलफिल करता है। तो ओके, आई होप दिस इज क्लियर। एंड कंटेंट लेंथ, हेडर यूज टू डिटरमाइन द एंड ऑफ द रिस्पॉन्स। तो कंटेंट लेंथ बेसिकली क्या है? कंटेंट लेंथ एक हेडर है which kind of determines which this header is used to determine the end of the response. Okay, chunking transfer encoding for dynamic contents allow data to be sent in chunks मतलब क्या होता है? जब सर्वर को नहीं पता होता कि इस पर्टिकुलर इमेज की या फिर इस पर्टिकुलर रिस्पॉन्स, या फिर काइंड ऑफ जब जब सर्वर को बेसिकली नहीं पता होता कि ये पर्टिकुलर जो भी आइटम है, इसकी क्या कह सकते हो, इसकी कंटेंट लेंथ क्या है, मान लो मतलब जो मेटा डेटा है उसमें नहीं दिया गया है कि कंटेंट लेंथ क्या है इस पर्टिकुलर चीज़ की, तो वो बेसिकली अपने से क्या करता है, वो बेसिकली जो जिस चीज़ को भेजना है उसे वो क्लाइंट को भेजना है सर्वर को, वो बेसिकली उस चीज़ को थोड़ा सा इट जस्ट चंक्स इट इनटू पार्ट्स, कि ये पार्ट वन है, ये पार्ट टू है, ये पार्ट थ्री है. So even though like it does not have like the server does not have any idea of the content length of the object या फिर of the thing, it will just make chunks from its own. Okay, and उसके बाद basically enhanced caching है, better like adds like and proxy author. Okay, let's ask about this also. And yeah, enhanced data compression, new standard. Okay, so actually I think like the video chat, voice mode length is over for this kind of this chat. So I will gonna like call it again and I will ask the same question. So actually, when you say like chunked transferred encoding for dynamic content allowing data to be sent in chunks, I'm just going to tell you what I understand when you say that, and just kind of correct me if I'm on the right track. So like when the client asks the server for a particular resource, the server kind of looks at it and then sees if it can find like the metadata, the content length, and if there is no content length, the server takes the resource and kind of divide it into chunks and then send it to the client. So that is what I understand when you say chunked transfer protocol, transfer encoding. And the second I want to ask is when you say enhanced authorization adds added digest and proxy authorization. So what do you mean by digest and proxy authorization? I can read the terms but I don't understand what's like the difference. And the last thing I would ask is like what are the new like status codes in http 1.1, and what do they even do? So okay, like I was like guessing the chunked transfer protocol, like the churn. Why do I say it is protocol? It's like encoding, chunked transfer encoding. So I was pretty much on the point on that one. And the digest, like the only thing, the like instead of sending passwords in plain text, it uses like a hash function to encode credentials. So it is like it just hashes them. And the proxy authorization on the other hand, it specifically used when you are connecting through a proxy server. It allows the proxy to authenticate itself to the client or the server. Achha, you said like is specifically used when you are connecting through a proxy server. It allows the proxy to authenticate itself to the client or the server. The thing is, I don't understand what is like a proxy and what is like a proxy server. Like explain it to me like I am like a fifth grader. Like I'm a fifth grader. Is like DNS, like if you use like a DNS server, is it like considered at like a proxy server? No, 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 no. Listen to me. Actually, I use like a DNS service called like 1.1.1.1 by like Cloudflare. So it's called a DNS server. So is it like a proxy server? Like when I enable it, what happens? So okay, I understand now. Actually, I do understand now. Like, see, I was again, I got into like a rabbit hole. Like, I was like, yeah, let's understand. So, okay, these are like different things. The last question I want to understand. So actually, when I was like reading this article where it was like know everything about HTTP, I actually gone through like a sentence where it was like the writer kind of denies to explain everything about HTTP 1.1. So it like he gives me like a link to like other websites and other documentation resources. So he said that can you explain me what are the key or like the core differences between like HTTP 1.0 and HTTP 1.1 in like a point wise way. So okay, now you understand like in the persistent connection part, the HTTP 1.0 did not like use it like was and this is means that the same connection can be used. This reduces improvement. Okay, why is separate by default? So by default it uses like the persistent connections like the HTTP 1.1, but on like 1.0 it was not like by default, it was like given like people were doing it but it was not supported. And like the chunk transfer encoding also got like in 1.1. So which is like which allows data to be sent in chunks, which was greater for streaming and dynamic contents. Okay, And in like header hosters, I gave you the example like every server has like IP, and like the host header helps the like you helps you to like host multiple kind of websites on like the same server on the same IP, because every device which like, can kind of gets connected to the internet has like a internet protocol IP address they have. So yeah. And the crashing improvement, okay, like it was like a thing. And like there was like more like status codes and methods which we kind of discussed. And pipelining, as you can know, it's like allows multiple requests to be sent out without waiting for the previous response, which can be which can improve efficiency. Okay, so now we are done on like the http 1.1, almost like everything we have discussed. Now we will go to like spdy. Oh my god. Okay, this is like a very small one. Let's do it. So now I'm going to read something and explain it to me like in like simple terms. So let's start. SPDY 2009. Google went ahead and started experimenting with like with alternative protocols to make the web faster and improving web security while reducing the latency of web pages. In 2009, they announced SPDY. SPDY is like a trademark of Google and isn't a acronym. It was it was seen that if we keep increasing the bandwidth, the network performance increases in the beginning, but a point comes when there is not much of like a performance gain. But if you do the same with latency, that is, if we keep dropping the latency, there is like a constant performance gain. This was the core idea for performance gain behind SPDY, decreasing the latency to increase the network performance. For those who don't know the difference, latency is like the detail. Latency is the delay, that is how long it takes for data to travel between the source and destination, measured in milliseconds. And bandwidth is like the amount of data transferred per second, bits per second. The features of SPDY included multiplexing, compression, prioritization, security, etc. And I'm not going to get into the details of SPDY, and you will get the idea when you get into the nitty-gritty of HTTP 2 in the next session. As I said, HTTP slash 2 is mostly inspired from SPDY. SPDY did not SP didn't really try to replace HTTP. It was a translation layer over HTTP, which existed at the application layer and modified the request before sending it over to the wire. It started to become a de facto standards, and majority of browsers started implementing it. In 2025, in 2000 no in 2015 at Google, they didn't want to have competing two competing standards, so they decided to merge it into HTTP while giving birth to HTTP2 and replicating SPDY. So can you give me like the keywords which will kind of summarize HPDY? Can you explain multiplexing and like parallelism, to like a fifth grader? So like I hope you understand the example. So it just lets you like you can just you can do like multiple, like you can the client can ask for multiple requests, like can kind of ask for multiple requests from the server without waiting for the response first. You know what I mean? This is what like the gist of like this is what like ChatGPT is saying. Like, it's like the gist of like the essence of this. Okay, so let's go into like HTTP 2 2015. So I'm going to read this and just explain it to me like in simple terms. Here we go. HTTP to 2015. By now you must be convinced that why we needed another revision of the HTTP protocol. Um, by now you must be convinced that why we needed another revision of the HTTP protocol. HTTP2 was designed for low latency transport of content. The key features or differences from the old version of HTTP 1.1 includes binary instead of textual, and multiplexing, multi asynchronization, synchronous HTTP request over a single connection, header compression using HPAC, server push, multiple responses for single request, and request prioritization security. Binary protocol HTTP2 trends to address the issue of increasing latency that existed in HTTP 1.x by making it a binary protocol. Being a binary protocol, it is easier to face, but unlike HTTP 1.x, it is no longer readable by the human eye. The major building blocks of HTTP2 are frames and streams. Frames and streams. HTTP messages are now composed of one and more frames. There is a headers frame for the metadata and data frame for the payload, and there exist several other types of frames: headers, data, RST stream, settings, priority, etc. And you can check through the HTTP specs. Every HTTP to request slash response is given a unique stream ID, and it is divided into frames. Frames are nothing but binary pieces of data. A collection of frames is called a stream. Each frame has a data stream ID that identifies the stream to which it belongs, and each frame has a common header. Also, apart from stream ID being unique, it is worth mentioning that any request initiated by client uses odd numbers, and the responses from the server can be even uh, numbers, stream IDs. Apart from the headers and data, another frame type that I think worth mentioning here is RST stream, which is like a special frame type that is used to abort some stream. That is, client may send this frame to let the server know that I don't need this stream anymore. In HTTP 1.1, the only way to make the server stop sending the response to the client was closing the connection, which resulted in increased latency because like a new connection has to be opened for an convention uh, uh, and consecutive request to be open for consecutive requests. While in HTTP2, clients can use RST stream and stop receiving a specific stream while the connection will still be open and the other streams will still be in play. Multiplexing, since HTTP2 is now a binary protocol and has, as I said above, that it uses frames and stream for request and responses. Once a TCP connection is opened, all the streams are sent asynchronously through the same connection without opening an additional connection. As in return, the server responses in the same asynchronous way. That is, the response has no order. The the client uses the assigned stream ID to identify the stream to which a specific package belongs. This only solves the head of the line blocking issue that existed in HTTP 1.x. That is, the client will not have to wait for the request that is taking time, and other requests will be getting processed. Header compression. it was part of the it was part of the separate RFC, which was specified aiming at optimizing the send headers. The essence of it is that when we are consistently accessing the server from a same client, there is a lot of redundant data that we are sending in the headers over and over, and sometimes there might be cookies increasing the header size, which results in bandwidth usage in increased latency. To overcome this, HTTP2 introduced header compression. Unlike in response and request, headers are not compressing in gzip or compress etc formats, but there is a different mechanism in place for header compression, which is literal values are encoded using Huffman code, and a headers table is maintained by the client and server, and both the client and server omit and any repetitive headers, that is user agent etc in the sub squeeze request subsequent requests and refers them using the headers table maintained by both. While we are talking headers, let me add here that the headers are still the same as in HTTP 1.1, except for the addition uh, espesto headers, that is method, scheme, host, path. Server push is another terminus feature. अरे क्या is another tremendous okay, it is another tremendous feature of HTTP2, where the server, knowing that the client is going to ask for a certain resource, can push it to the client without even client asking for it. That example, let's say a browser loads a web page, it parses the whole page to find out the remote content that it has to load from the server, and then sends consequent requests to the server to get that content. Server push allows the server to decrease the round trips by pushing the data that is known that client is going to demand. How it is done is server sends a special frame called push promise, notifying the client that hey, I'm about to send this resource to you. Don't ask me for it. The push promise frame is associated with the stream that caused the push to happen, and it contains the promised stream ID, that is the stream on which the server will send the resource to be pushed. Request prioritization: a client can assign a priority to a stream by including the prioritization information in the headers frame by which a stream is open. At any other time, client can send a priority frame to change the priority of the stream. Without any priority information, server processes the request asynchronously, that is without any order. If there is priority assigned to a stream, then based on this priority information, server decides how much of a resource need to be given to the process which is requested. Security: there was extensive discussion on whether security through TLS should be made mandatory for HTTP2 or not. In the end, it was not decided to make it mandatory. However, most vendors stated that they will only support HTTP2 when it is used over TLS. So, although HTTP2 doesn't require encryption by specs, but it has kind of became mandatory by default anyways. With that out of the way, HTTP2 when implemented over TLS does impose some requirements, that is a TLS TLS version 1.2 or higher must be used. There must be a certain level of minimum key sizes, and environmental keys are required, etc. So give me like the keywords for it, like to summarize HTTP2. Okay, like I kind of understand what a binary protocol means, but can you explain it to me like I'm like a fifth grader again? Okay, so like we kind of convert, like like in like English language you will say like let's go to like that website, to kind of it just converts that sentence into binary, so it can read it quickly and more effectively and reliably, for computers. So like yeah, this is what the binary protocol does. So I hope you understand. And we are at the end of the article. I thought I will be like reading all of this, but I let me see how long the recording is. Like literally it is 2 hours. Like I know I will be like editing a lot of it, like all the like silence parts. And let's I will like kind of leave it here. And I hope you like the new format. I'm trying to like improve on how I record my videos and really add value to you guys. So if you have any issues or like you want me to change something, please comment it down. I'm looking for suggestions, I'm open for them. So I hope you learned something from this, and I hope you enjoyed this study session. So yeah, this is all for this study session. I will see you next time. Till then, take care. Bye.